Okay, so just to finish number 16 here, or 18 here. So when you divide your R by your lambda, you end up with 15.6. So that means lambda, R is 15.6 times bigger than lambda, okay? So if you were doing a fraction of lambda over R, to be 1 over 15.6, which your textbook, of course, rounds to 16. All right, last one is number 19. And number 19 says, an electron has a de Broglie wavelength of 400 nanometers, and there's a little star thing by it, which means it's a hard one. And it wants you to find its velocity and then the energy in electron volts. So part A, I think the star is here because you have to rearrange H over mv for V, but trusting that you can do this without too much difficulty. So V is equal to 6.626 to the negative 34 joules seconds. Rearrange, it's an electron, so 9.109 to the negative 31 kilograms, and this times the wavelength on the bottom, 400 to the negative 9 meters. And when you do this, you get a speed of 1.8185, 1.8185 times 10 to the third meters per second. And then part B wants the energy, so EK, which is equal to 1/2 mv squared. So 1/2, that 9.109 to the negative 31 kilograms times 1.81853 times 10 to the third meters per second, and it gets squared. So EK in joules is going to be 1.5062 times 10 to the negative 24 joules. And then to switch to electron volts, divide by 1.602 to the negative 19 joules per electron volt. And you end up with an EK of 9.402 times 10 to the negative 6 electron volts. All right, so there they are, your homework questions. Not to worry, I will be signing the other ones.